All right, so earlier on, I had also mentioned that volcanoes don't always fall along plate boundaries, and sometimes they can be found far away from any plate boundary. And we actually call these hotspots. All right, so these hotspots, basically, scientists hypothesize that these hotspots are usually hot regions of Earth's mantle where we have high temperature plumes of magma beneath the surface that are rising. So, some of the Earth's best known volcanoes formed as a result of a hotspot. One of the best known examples are the Hawaiian Islands, which are located actually just over a plume of rising magma. So the hotspot remains stationary, and in this case, right, we have the stationary hotspot, and the Pacific plate is sliding over top of it. So what happens is over time, the hotspot has actually left a trail of volcanic islands on the floor of the Pacific Ocean. And the volcanoes on the oldest Hawaiian island of Kauai are inactive because the island no longer sits above that stationary hotspot. So right now, the most one of the most active volcanoes, Kilauea, is found on the Big Island of Hawaii, and this is currently located over the hotspot. Now, not for long, over the next few thousand years or so, or many thousands of years, we have another volcano that's currently being created off of the uh, eastern coast of Hawaii, known as Loihi, and it's hasn't come to the surface yet. It's still currently beneath the waves and quite deep in the ocean. It's actually forming on the seafloor, all right, southeast of the Big Island, and will eventually take the place of the Big Island. The Big Island will slowly move off to the west, and the volcanism on the Big Island will stop, and Loihi will continue to be the new volcano that where all of the rising magma is going to be kind of released from. Eventually, that's going to build up and form a new island. So we talked about hotspots that occur beneath the waves, right, beneath the ocean, and we also have a hotspot that can occur underneath continental crust as well, and these are known as flood basalts. All right, so flood basalts are when hotspots occur beneath continental crust. They can actually lead to the formation of these flood basalts, and flood basalts form when lava flows out of these long cracks in Earth's crust, and these cracks are called fissures. So we have this fissure that has this split, that magma from deep below is filling in the gap, and what can happen is that because that pressure is being released, a lot of magma can come out and literally create a flood of lava in multiple directions around that crack or around that fissure. So over hundreds or even thousands of years, these fissure eruptions can form big flat plains called plateaus. And as in other eruptions, when lava flows across Earth's surface, water vapor and other gases are going to escape as well. So a lot of times it's actually quite dangerous to be in these areas. So looking at some past flood basalts, right? One example is the Columbia River basalts. And the volume of basalt that erupted by this fissure eruption, this flow out of this crack in the Earth's surface, can actually be quite tremendous. And the Columbia River basalt actually shows that. So the Columbia River basalts, located in the northwestern U.S. in the states of Washington, Oregon, and Idaho, actually contain roughly 170,000 cubic kilometers of basalt. That's a tremendous amount. So this volume of basalt could actually fill our biggest lake, Lake Superior, the largest of the Great Lakes, right? 15 times over. So it's a tremendous amount of lava. Now, the Columbia River basalts are actually quite small in comparison to other ones that have occurred. One of these is known as the Deccan Traps. So, taking a look at the Deccan Traps, about 65 million years ago in India, um, which we'll actually talk about this kind of time frame a little bit more later. But about 65 million years ago, it's kind of odd that at the same time, this is kind of the end of the dinosaurs, right? 65.5 million years ago or so. So during kind of right around the same time as the end of the dinosaurs, we have multiple theories, which we'll actually get into a little bit later and talk about that. But we have this huge flood basalt eruption that created an enormous plateau called the Deccan Traps. And the volume of basalt in the Deccan Traps is estimated to be about 512,000 cubic kilometers. Now, that volume, just to kind of give you an idea, would actually cover all of the state of Pennsylvania with a layer that is 2.5 miles thick. A tremendous amount of lava. So, some geologists actually hypothesize that the eruption of the Deccan Traps caused a global change in climate that may have contributed to the extinction of the dinosaurs. Again, we'll come back and actually talk about dinosaur extinction, that event, a little bit later. All right, guys, so let's take a look at the anatomy of a volcano. Recall that when magma actually reaches the Earth's surface, we call it lava. So lava reaches the surface by traveling through a tube-like structure called a conduit. Now, that conduit eventually will come to an opening, and we call that the vent. So as lava flows through the vent and out onto the surface, it cools and solidifies around the vent. And over time, layers of this solidified lava are going to accumulate, or anything else that's coming out of the volcano, right? It's going to accumulate and form a mountain known as a volcano. So at the top of the volcano, around the vent, is a bowl-shaped depression called a crater. The crater is connected to the magma chamber by the conduit. Now, volcanic craters are usually less than 1 kilometer in diameter, so not usually too big. I mean, 1 kilometer is still fairly large. It's about 0.62 of a mile. But larger depressions, we call them calderas, can be up to 100 kilometers in diameter. So calderas often form after the magma chamber beneath the volcano empties. And since you have this big empty pocket from this major eruption, the summit or the top of the mountain, or sometimes even the side of the volcano, will collapse into that empty chamber, leaving this giant circular depression. So after the surface material collapses in on itself, water will sometimes, depending on where the volcano is, water will sometimes fill that caldera, and they form these beautiful scenic lakes. One example of this is known as Crater Lake, and you can find it in southern Oregon. It actually formed when Mount Mazama collapsed around 4,900 BC. So quite a while ago. But you see that actually down here in the lower portion of this lower picture. The picture that you see on the top here is actually where Mount Santorini once stood in the Aegean Sea, or in the Mediterranean, in the Eastern Mediterranean.